quartiles, in a way, are a special kind of percentile. But where percentiles divide a data set up into 100 parts, quartiles divide a data set into fourths, quarters. Here's an example of a data set. There's 12 data points in our data set. Now, I'm not going to put numerical values to those because that's irrelevant just to the idea. But anyway, since there's 12 data points, 12 observations in our data set, each quarter of the data set is going to have 3 observations in it. So let's see, I've got 1, 2, 3. I'm going to start from the left to the right. So I'm going to make a mark halfway between the last of the first 3 and the first dot in the next 3, and then 3 more dots, and then 3 more dots, and that's it. So we've divided our data set up into 4 groups of 3. So in this first interval, we have 1/4 of the data set. Then in the next interval, we have another 1/4 of the data set. And then in the next interval, another quarter of the data set. And then we have the last quarter of the data set. Notice that these intervals are not necessarily the same length. So what we're not saying that we're taking this whole range of the data set and dividing it up into fourths that way. No, we're dividing it up into equally numbered groups of data points. There's some names for these red marks that I've made in here to separate our data. This first mark is called the first quartile, which we'll symbolize with a Q sub 1. The second mark is called the second quartile, Q sub 2. The third mark is called the third quartile, Q sub 3. So there's Q1, Q2, Q3, dividing the data set up into fourths. And hopefully you remember that there's another name for the middle of a data set where you have half the points below and half the points above. That's also called the median, which we will symbolize with an M. Now with percentiles, I talked about them a little bit because I wanted you to understand them, but I didn't ask you to compute any percentiles, and we're not really going to need to compute percentiles, at least at this point in the course, but we will want to be able to compute quartiles. So let me give you a procedure for that. First, you're going to put the data in order from smallest to largest and find the median. Remember, we have to put the data in order to find the median. Once we found the median, which we can call M or Q2, so we've found this. Next, we're going to find the median of the data below Q2. So we look below Q2, below the median, and we find the median of that half of the data, and that's our Q1. Then we look on the other side of the median. We find the median of that half of the data set, and that gives us Q3. Let's do an example with actual numbers now. So let's find the quartiles for this data set. The first thing I need to do is put the numbers in order. So let's see, we have 1, and then 2.5, and then 3. There's 2 3s, don't forget to write them both down. What's next? We have a 5.5, a 6, a 7, 9, 10, and 11. Now to find the median, we have to notice whether we have an even number or an odd number of data values. There are 10 data values. And the point is that's an even number of data values. So the median is going to be the average of the two middle data values. So let's see, where's that? 1, 2, 3, 4, 5. 5.5 is the fifth one, so the median is going to be in there, and that's going to be the average of 5.5 and 6, which will work out to be 5.75. And if you're handy with decimals, you might just have realized that that would have to be 5.75 to be halfway between 5.5 and 6 without even doing the computation. So that's our second quartile. Now we look at the data values below the median, and I need the median of those. Again, to find the median, I have to start by asking myself, do I have an odd number or an even number of data values? And in here, there are 5 data values. I'm just going to call those values. I'm going to abbreviate that. So that's supposed to be VALS for an abbreviation of values. So anyway, we have 5 values, and the point is that that's an odd number of values, so the median of those, which is our Q1, will just be the middle number. And the middle number there is this first 3. So Q1 is 3. Then we do the same thing for the upper half of the data set. And once again, there's 5 numbers in there. So the median of that set of numbers is the middle number, which is 9. So our Q3 is 9. So the quartiles are, just to write this out in a nicer order, we have Q1 is 3. Q2 was 5.75, and Q3 is 9. Now I realize that my little picture up here was a little too simplistic. We're not always going to have a data set that divides evenly into quarters, but I wanted to make a nice simple picture just to get the idea in there. Our quartiles now, in this case, because you can't split 10 data values up evenly into quarters, but notice that there's an equal number of data values between each of our quartiles. So we've got a group of 2, a group of 2, a group of 2, and a group of 2. And they're separated by these 3 numbers. 2 of those numbers, Q1 and Q3, happen to be part of the data set, so they don't really count in the splitting up. But anyway, that's the idea of quartiles.